why the fence is the seat of reason.
Okay, thank you. Good morning, everybody. My title will kind of give away somewhat what conclusions I'm expecting to reach. But the couple of things I need to say first. Obviously, this subject that we're all addressing at this whole workshop is quite wide, and there are many different aspects. So I'm taking a very narrow aspect, a very narrow view of one aspect in order to fit it into the time available. So I expect lots of people to say at the end, but what about this, what about this, and what about this? And I'll say, well, that'll be in other people's presentations, probably. So all I really want to do is look at argumentation theory. This is what I'm involved with. I don't know how many people are kind of interested and know much about this. I want to just look at how argumentation theory deals with expert testimony, and particularly if it has any way of dealing with disagreements between experts. Okay, and as the conclusion, as you can see, the title is "Why the Fence is the Seat of Reason." This will suggest that sitting on the fence is probably the reasonable thing to do if we go by argumentation theory. And again, I'm not suggesting that that's the only possible way to go. Okay, so if I just go through the plan, I'm going to make some general comments about argumentation first, and then some general comments about expert disagreements. Then I'm going to look at how argumentation theory deals with experts. I ought to maybe just point out now, again, argumentation theory is obviously quite a big collection of stuff. So by argumentation theory, what I really mean is I'm looking at Douglas Walton's argumentation schemes, which are probably the starting point for everyone else in argumentation theory who talks about experts. They start with Walton's schemes, so that's the place to start. So for some of you, you may be very familiar with those already. I hope it's not going to be too simple for you, but we'll see. When I say on numbers, this is not to do with mathematics. I mean simply the idea of adding up, whether we can look at arguments ad populum and use those to help make decisions when experts are not in agreement. And the last scheme that I'm going to look at is a more pragmatic way of making decisions when practical reasoning is necessary, even if we can't actually form we don't have a good reason to form a particular belief. And maybe there will be some kind of combined scheme at the end for expert disagreements, but this is with the question marks, so maybe it depends how far we get in the time available, whether we can agree on anything. Okay, so this is what I'm going to be arguing. I wanted to make this clear rather than kind of leave you to work out what it is I'm saying as we go along. Argumentation schemes actually expose the impossibility of comparing expert testimony. Again, I don't mean to say that it is impossible. I mean to say that argumentation schemes make it look impossible. So, that might be a reason for rejecting argumentation schemes. Suggestions of methods for comparing experts by laymen are impractical. This is something I'm just going to kind of say and not really argue for, and probably you're all going to disagree with me. But that's something else that we can get to later on. As a result, the rational decision is very often to sit on the fence and not commit to either view. And the people who are determined to commit to one view or another are being irrational. And I think that, for example, things like climate change provide very good examples of this, that it seems to me that basically everybody in the civilized world is determined to have a view on climate change. And either they're on this side or on the other side, even though they are not in any position to actually judge the evidence themselves. And probably it would be more rational of them to at least to some degree be on the fence rather than fully committed. I'm going to obviously suggest when action is required, then we need to look at some pragmatic factors. But I'm going to reach the conclusion that there isn't actually an easy method which we can put into play every time, right? And that every case, in fact, will be different when it comes to the pragmatics of decision making. And expert advice. So we come back to the first one. Expert advice can only ever be one factor. The last thing that I've got on here, which again might be quite controversial, I'm going to suggest that genuine expert disagreement is actually extremely rare. And I'm going to say why as we go along. Obviously, the word genuine has a lot to do with that. Okay, so some comments on argumentation. Argumentation theory generally is very good at some things and not so good at others. Argumentation theory is very good at setting out forms of arguments, patterns of arguments, which allow us to compare when one argument is the same as, or of the same form as another one, or it's different. And it's very good at allowing us to identify the weak points of a particular argument, and this is often reflected in the critical questions, which are generally connected to argumentation schemes. However, argumentation is pretty bad at resolving problems when there are conflicting reasons, because we do not have a good system of judging argument strength. This is like the holy grail for argumentation theorists, is to get a good system for judging argument strength so that we can add up arguments and we can say this one is stronger than these three and so on. But at the moment I would say that there's really no even good contenders for this role. But a lot of people are working on it. Okay, so I'll be using the schemes that Walton gives in his book. It's actually Walton, Reed and Magalno, 2008, where he gives a list of 60-something schemes which he thinks are all separate arguments. I don't agree with him, but we'll come back to that. Okay, before maybe this is going to be kind of obvious given the whole theme of this meeting. Just to make it clear that when we talk about expert disagreement, we separate the two questions: what experts should do when they disagree amongst themselves, and what the rest of us should do when experts disagree. So if it's in terms of experts disagreeing amongst themselves, there are various procedures for trying to obviously reach consensus. But I think most people here will be concentrating on the second question, which is the question of what we should do when we have conflicting expert testimony. Okay, so I'll be focusing on question number 2. Okay, on expert disagreement generally, for the purposes of this talk, I'm making 3 assumptions. The first one is that it makes sense to talk about experts and to assume that we can identify experts. Okay, so there's a lot of people would debate that. The second one is that once we have identified experts, they can actually disagree within their fields, that it is possible to have expert disagreement. And what that leads to is this third idea that it's possible for experts to disagree without either of these experts, let's say there's just 2, losing their expert status. Because there is a kind of tendency, as an intuitive idea, to think that if 2 experts disagree, then one of them is not really an expert. And it's a question of finding out which one is not actually the expert. But then, if we look at it like that, then we're not really talking about expert disagreement, we're talking about ways of characterizing experts. And so I'm assuming that we've already got a good way to characterize experts. Having gone through that process, we still have disagreement between 2 of them. So I've put on here, it's a form of faultless disagreement. Faultless disagreement, of course, is something different, I know. So this usually refers to adjectives and things like tasty. I think it's tasty, you don't think it's tasty, but nobody's wrong. So I'm suggesting that we can have something analogous for experts. One thinks P, one thinks not P. Of course, one may be wrong, they may both be wrong, but not P and not P, but on other issues they may both be wrong. However, that being wrong is not catastrophic for their expert status. So we don't dismiss them as experts because they disagree. So we're not looking at who is the real expert, but we're just comparing these 2 particular cases. Okay, I'm not sure about any of these 3. Okay, so I'm not arguing that these 3 are true. In fact, I'm quite doubtful on probably all of them. But for the purposes of the presentation, that's what I'm assuming. Okay. So the first 3 schemes that Walton gives in his big compendium are argument from position to know, argument from expert opinion, and argument from witness testimony. And in 2 weeks in Switzerland at the European Conference of Argumentation, I'll be arguing that this is a mistake to separate these, if anybody's going to be there. Because in fact they all have the same structure. But anyway, Walton's scheme for expert opinion is, I say, superficially uncontroversial, the basic part of the scheme, and it's the most well-known and one that everybody kind of focuses on in argumentation theory. Okay, so it looks like this. We have major premise, source E is an expert in subject domain S containing proposition A. Minor premise, E asserts that proposition A is true. Conclusion, A is true. Okay, so someone is an expert, it's in their field, they say that it's true, so we conclude that it's true. That's basically how it works. This gives rise, according to Walden, to 6 critical questions. You can read all those: expertise, field question, opinion question, trustworthiness, consistency, backup question. These have been criticized a lot by people in the field, and some of them are better than others. Walton then produced a kind of longer explanation of each one. For example, how credible is E as an expert source? For me, that's just kind of determined by the others, but in Walton's bigger expansion of credibility, he talks about things like positions at university and degrees, and so it's credibility in a sort of public sense. One of the things worth mentioning, we've got the consistency question. That this is, it seems to be kind of circular, right? So we trust our expert if he agrees with other experts, which means that we need to have identified these other experts and know that they were also consistent with other experts before we can take their opinion seriously. So we seem to be going around in a circle. And it's also a problem if you have some kind of new subject which nobody has studied before. If we already know what's the fixed opinion of most experts, then why would we be looking at a new expert anyway? So by consistency, it's better to understand that he means someone whose methods and general approach are consistent with what we consider experts in the field. Not necessarily the exact result that this person has achieved on this time, and the exact advice is consistent with others, because we may not have a view which we can accept as the accepted one, and if we do have an accepted view, then right, why are we looking at what this person's view is? Okay, I think that's all I need to say about those. That's a little bit small. So there are some internal shortcomings. Wagner's has a nice critique of those. But obviously it does nothing to help if there are two opinions we have two conflicting opinions which can go through all the 6 critical questions without any problem. Assuming that that's possible. If that happens, then we're stuck. We have a reason to believe on one side and we have a reason to believe on the other side. On this model, all experts, once you're defined as an expert, you're treated equally. Okay? And there is no way to compare. If we take things like credibility and trustworthiness, right? If credibility is based on someone being a professor at a university, we can't say that if someone else is a professor at 2 universities, we should believe them and not the first one, right? That doesn't make sense. The same with trustworthiness. I mean, if someone is generally honest and another person is like a saint, this doesn't mean that the person who's the saint is going to be more right than the person who's honest, right? I mean, if we believe someone's being honest, they're being honest, and that's it. You can't add these things up. So there isn't any way using those criteria to somehow reach a score for how good our expert is. Other proxies for experience, so things like track record and just experience, these things, these things, I don't want to get into this too much, it's a big field, but I think that these things are impractical. And it isn't easy to see really how they would fit into this scheme anyway. You'd have to pretty much change Walton's view of experts. Okay, so if it's possible for 2 conflicting opinions to stand, we're left with reason to believe both of them and no reason to prefer the other, so we're stuck on the fence. Okay. So we can try a different version of the scheme. So this is my version. And it has a couple of advantages, in my opinion. So we've got witness W testifies proposition P is true. It's reasonable to believe that W is in a position to make valid claims about P. Therefore, it's reasonable to believe that P is true. This switch, that they're in a position to make valid claims, this gets us past one of the problems that was in the last presentation about experts on ethics. So under Walton's scheme, if you've said someone's an expert on ethics, therefore they can say anything about ethics. Whereas here it's kind of explicitly pointed out that just because someone who's an expert on ethics makes some kind of ethical decision about abortion or something else, we don't happen to think that this person is in a position to make such claims. Okay? Someone is in a position to talk about what various philosophers have said about this ethical problem, or how we might address this ethical problem, but they are not in a position to make claims about what's wrong and right in this particular position. And I think very often when expert opinion goes wrong, it's because experts are giving opinions on things which are not actually within their rights, right? That they step outside of what they have, what their position gives them the right to say. So it also avoids questions of definition of expert and uncertainty over fields. This is what I talked about last year, was about problems with fields. And when we get the critical questions, we need to ask, does C pertain? So is this circumstance actually true? And does it put W in such a position? So does the circumstance that we're putting forward, which might be that someone is an expert or someone is a professor of, does it actually put them in position to make these kinds of claims? Okay. Unfortunately, although as I said, with ethics, that's great. It's a nice example because we can all say, well, just because you're an expert on ethics doesn't mean you know what's right and wrong, and that we can kind of understand that. But if we take astrophysics, and an astrophysicist makes a claim about other dimensions or something, it's pretty much impossible for the layman to know whether an astrophysicist has the right to make such claims, because we don't know enough about what astrophysics knows about other dimensions, for example, to know whether that's within his real competence or not. So still, for the layman, there's a problem here. Okay. I want to look at the idea about consensus. So putting it into argumentation terms, we can look at our ad populum arguments. So the general ad populum argument that Walton gives is like this: A is generally accepted as true. That gives us a reason in favour of A. If A is generally accepted, so there's a reason. So we have a reason in favour of A. As you can see straight away, that's a very weak argument, right? That lots of people say something's true, so that's a reason in favour, but that's not even exactly a reason to believe. We can think of lots of examples where lots of people think something, but we disagree, right? Or maybe even most people think something, but we disagree. Walton gives us a specific scheme for experts in this section, and as you notice, he uses the word everybody, right? So he says everybody in group G accepts A. G is a group of experts, therefore A is true. One thing that I didn't explain, maybe I don't know how familiar you are with the kind of theory behind argumentation schemes, is that most of these schemes are schemes of things which have been considered fallacies at times, but are generally now considered to be sometimes good arguments. So argument from expert opinion is generally very much in this group. This particular argument, though, is much more like a fallacy, simply because everybody in group G accepts A, but there could be another larger group of experts, right? So it's not all experts accept A, it's everybody in this particular group. And everybody in this group is an expert, but of course there could be other groups and they're also experts and they have different opinions. So this seems much more like fallacious reasoning. But anyway, so the first scheme is rather weak, and the second scheme is not very good because it's everybody. And as soon as we allow that it's not everybody, as soon as we allow that there is some expert opinion which goes against that consensus, well, then we have a reason to believe one, and we have a reason to believe other. The main point that I'm getting at here is that there does not seem to be any logical reason to discard the opinion of an accepted expert because it's contradicted by others. If he's an accepted expert, right, which means we've already gone through the consistency question and so on. So once we establish we accept that someone is an expert, then other people's giving testimony against them doesn't seem to give us any logical reason to discard their testimony. Okay, so of course I expect that some people will argue that in practical situations we can kind of, we were talking about in the questions the last presentation about this overwhelming force of opinion. But if one person is standing as still an accepted expert and has a different opinion, we still have a reason to think that could be right, and that gives us a reason to stay on the fence. Okay, this is probably what I just said. Yes, this is what I just said. So don't worry about that. It just shows us the limitations of argumentation schemes. But what do we do when we have to act on a belief? Okay, so we need some form of practical reasoning. This is a suggestion, this is what I call argument from caution. Walton puts this in a group of arguments from ignorance, and I think that he's wrong to do so, but it doesn't really matter. But he calls it argument from practical reasoning. I don't know whether A is true or not, right? So we've got conflicting opinion. I have to accept the presumption that A is true or not, so I have to come to some conclusion. So then we have, if I act on the presumption that A is true and is not true, I get some consequences. If I act on the presumption that it's not true and it is true, I get some other consequences. And we look at which ones are more serious. So what would be the more serious consequences of being wrong in one direction or the other? Now, obviously all arguments that relate to consequences have this big problem that one needs to know what the consequences are going to be. So Walton's example is a very simple example where the consequences are very, very easy to ascertain. So he has an example of a gun that's just lying around. I think it's supposed to be at a shooting range, but anyway, it's just lying around. And you don't know whether it's loaded or not. And on Walton's view, you've got kind of two ways you can behave. You can treat this gun as though it's loaded, and you can very carefully take it and put it away, or you can pick it up and start swinging it about, right? Which probably most people wouldn't do anyway. But the point being that the consequences of treating it if it's loaded when it's not loaded there's almost no consequences, right? I mean, it might take you a few seconds longer to put this gun away because you have to be more careful. The consequences of playing with this gun are that you might shoot somebody. So, of course, it's obvious in this case that it's a good idea to be cautious. Of course, what makes this case a little bit interesting is that the chances are that if you treat this gun as it's not loaded, but it is loaded, the chances are there won't be any consequences anyway, because probably you won't shoot anybody, unless you actually pick it up and start squeezing the trigger, which, again, this seems to be very kind of risky behavior. So it's a form of Pascal's wager. Right? We need to know what what the consequences would be, which is very difficult. I'm not so sure I agree with this bit anymore, so we'll just skip that. Changed my mind. So we can sum up this type of reasoning as better safe than sorry, and I wanted to go through just a few examples. So we have here more details on the MMR example that we came up in the questions last time. So this is for those who don't know, but probably most of you only from Britain will know about this. There was a paper in 1998 by a guy, Andrew Wakefield, which said that there was a link between MMR and autism. In this instance, it turned out that the original paper was simply fraudulent, right? It wasn't even just a mistake, it was deliberately fraudulent. So parents who wanted to be better safe than sorry were effectively tricked into not having this injection for their children on the basis of somebody's deliberately manipulative pretend scientific work. Okay, and I'll come back to what that means in a second. Some of you may remember some months ago that there was some concern that at CERN that they might create a black hole which would swallow all of us. I never really understood why people were bothered about that, because if it had happened, so what, right? I mean, that's it. I don't really see that as a bad consequence, is it? No one would know, right? So very strange. So there's a quote here from an American scientist who was connected, saying that we need the most compelling answer of all, and they say that they have a compelling answer. But again, if we take the better safe than sorry idea, then we could have said, well, they shouldn't do such experiments, right? The consequences if it creates a black hole and destroys all of us are huge, right? So they shouldn't do it. And the third example I got here, just before so it was a year ago now, just before the referendum on the EU in the UK, there was quite a controversial statement from the governor of the Bank of England, where he talked about the dangers of leaving the EU. He talked about the dangers, but he didn't talk about any possible advantages. Okay, well, some people might say there weren't any possible advantages, but that's a case of opinion. But he only looked at possible negative consequences. Okay, so the point about that is that if we have this argument from caution as our kind of way of deciding what to do when experts disagree, we end up being exposed to outlandish and emotional claims. Okay, the parents, when they're told that their children might get sick if they have this, parents will, even if it's based on no evidence, parents will still be afraid of taking any risk concerning their children's health. We're at the mercy of claims of extreme consequences. Okay, so again, the smallest amount of evidence could be enough to stop us doing something. And we might have a concentration on negative consequences, simply because we tend to look at risks, and sometimes the possible advantages can be swamped by concentration on risk. So we would still need a method to somehow compare these things. Okay, so rather than necessarily a scheme for what to do, this is just maybe a kind of opening thoughts on this topic. The process that we go through when we seem to have expert disagreement. So, do the conflicting parties have reasonable claim to expertise? That's obviously a big subject that many people want to talk about. Do we believe that they're being sincere? Then we need to find out what is the actual disagreement, and does the point of disagreement actually lie within the competence of the experts? And I would, this is another topic, but I would argue that actually it usually doesn't. That actually the real point of disagreement between scientists, between experts in other fields, is usually something which is not really their competence. They normally want something that goes slightly beyond it. Then we have to think about what is our goal. Is it action or belief? If we're looking for action, we have to do something. Then we're going to say, do the opposing views actually suggest conflicting courses? Okay. I'll just give an example of how that can work. If we take climate change, someone who believes that fossil fuel burning is destroying the environment will want to stop fossil fuel burning. Someone who doesn't, but believes in strong industrial growth and so on, may well come to the conclusion that stopping fossil fuel burning is the best way forward anyway, since a kind of free, cheap, or at least cheap green energy revolution would be the best way to revolutionize industry in the Western world, right? So you can have opposing views that don't necessarily lead to opposing actions. What's the degree of certainty? This needs to be taken into account, and what are the likely costs? If we're only interested in belief, then we could sit happily on the fence. And I think that generally we should sit on the fence more often and stop having strong opinions about things that we don't really understand. If we apply this quickly to those three cases, my idea was to apply it to the three cases. When I looked at the three cases, I discovered something. In the first case with the MMR scandal, this was not a case of genuine disagreement between experts, because it turned out that the experts who said that there was a link with autism were simply lying, right? They simply fabricated their case. So it's not genuine disagreement because, I mean, people didn't realize at the time, but they were not trustworthy. And in fact, as it mentioned earlier on, in their study they had 12 cases in their study, which means really the whole thing was a massive failure of peer review, because a very controversial claim was published in The Lancet on the basis of 12 cases. Who peer reviewed it? And the journal was very reluctant to. They sometime later they published a little square saying, well, sorry, it was wrong. And such a prestigious journal with such a controversial conclusion, it's a real failure of peer review. So the system is already in place that should have stopped that. Maybe you know much more about it than I do. Okay, so but just
the facts are that the article in the Lancet didn't say there was a link between MMR and autism. It actually said there was a link between MMR and measles virus in the gut, which doesn't necessarily lead to autism. So it wasn't a failure of peer review. Small numbers, poor article.
Okay, all right, that's.
His announcement about the link between MMR and autism was made in the press conference later.
Okay, all right. For the parents, that doesn't make any difference.
Yeah.
The other question, with the one about black holes, it turns out that there are two types of black holes, and the type of black hole that eats everything is not the type of black hole that could have been created. So the people who were worried about this creation of black holes were people who listened. No, they listened to the particle physicists who said that there could be a black hole, but they didn't listen to the same particle physicists who said, but it's not that type of black hole. They just said, it's a black hole. So in fact, there was no expert disagreement because the people who thought that there was a danger were not actually experts, they just hadn't understood the experts. And the third one, although Carney's intervention was politically very controversial, he uses the word could many, many times in his press conference. He never uses the word will. So, in fact, an economist who was pro Britain leaving the European Union could not have disagreed. It wasn't possible to disagree with him because what Carney said was that if there's a vote to leave the European Union, there could be less investment, there could be higher unemployment, and there could be a technical recession. All of which could happen with or without these votes on any particular month, yes, there could be a recession. So, in fact, the disagreement was over whether it was Carney's role to make such an intervention or not over the economics of what he said. And whether it was his role, because in Britain obviously we don't have a constitution that tells people what their role is, it was a political decision to say something or not to say something. Okay, so in all of those cases I would say that there was no real disagreement. This is just a scheme that shows what happens when there's conflicting testimony. One says P, one says P is not true. We can't believe both. If we have reasonable reasons to believe that both could give us a good answer, then it's reasonable for us to be undecided about the truth of P. Okay, thank you.
Thank you for addressing some of the main concerns of when experts disagree and using examples relevant to our project. I should have mentioned that my co-PI, Luke Drury, who is an astrophysicist, is giving a paper on astrophysics in Moscow right now. So he sends his apologies. He could not be here. I'm going to try and take questions from people who didn't have a chance to speak last time. So if you can hold your hand, Jane Master.
So I appreciate your shifting attention from finding out what is the right answer when experts disagree to the practical question, which is what should we do when experts disagree, which may not involve finding the right answer, but has to involve some way to move forward successfully. I think you underrate precaution because we do buy insurance. So sometimes we use the precautionary principle. Sometimes I think you're right, we use no regrets principle, like we try to find a way that whether or not P is true, things will be better off. There's one other strategy that's emerging, and it would be adaptive management. Like we take a guess right now and say, okay, let's assume P is true and let's make a policy based on that. But let's also commit ourselves to every year finding new evidence about, the fact that we adopt a policy and go in a direction is going to produce more information. And so let's commit ourselves to re-examining our policy on a regular basis, gathering that information and seeing whether we're right. So like in the MMR case, even if you wanted to say, okay, I'm afraid of the MMR, I'm afraid of the jab, well, let's go on, and 10 years later you find measles rates are increasing and there's no change in autism, so then it gives you the opportunity to rethink. So it's using the policy process as an experimental process to gain more knowledge and kind of resolve. Do you think that there's even more, like would you be happy about studying more of these practical ways that we manage this problem?
I think there's almost an infinite number.
Yeah.
And that's why I think it's not possible for us to say, okay, this is the principle we should use, and this is the kind of procedure to use, because every case will be different. And I mean, the cautionary principle is fine. I buy insurance too, but only up to a certain price level.
Yeah.
Right? If it gets too expensive, then the balance of consequences, possibilities, we say, okay, I'm not going to buy that because the chances of this happening are so low, and this is too expensive. But we make these decisions balancing different factors, and I don't know that it's possible to write out schemes on how we do it. We just do it. Yeah.
But notice that we're not sitting on the fence, which in the world of action is not really, is usually a dispreferred, doing nothing.
In the world of action,
not
yeah.
even allowable.
But I think we can act without actually forming the belief that this is true, right? We can have, for a reason such as caution, we say, I don't know if it's going to happen or not, but because of the possible bad consequences, I'm going to take this action anyway.
Just one, right at the beginning of your talk, you said there's not much disagreement among experts. I thought that was very odd claim, since we have a thing called peer review, and physicists at least are always organising different teams of people within their own team to disagree. But I would have thought that disagreement among experts was actually a pretty universal phenomenon, and something that experts use to reach a conclusion. They argue among themselves. Now, the point that follows is that why shouldn't we be sitting on the fence? Shouldn't we rather be delegating to bodies of experts to argue among themselves to reach a conclusion for it? Isn't delegation the answer rather than sitting on the fence?
I mean, of course, we hope that they will reach a conclusion amongst themselves. Well, when I say that there's not genuine disagreement, I mean, if we're talking about the forefront of science, the cutting edge stuff, you could argue that nobody is an expert in that stuff. People are experts in the stuff that comes up to that point. They're experts in the methodology, and they would mostly agree about the methodology and agree about the background science. But something which is completely new and radical and creates a lot of disagreement between people, I think it's legitimate to say that there isn't really anybody who is an expert on that topic, in the sense of someone that we can reliably, think knows the answers on that topic, right? They know the questions in that topic. But
Yeah, go ahead.
I think that's only the case if your model of expertise is people who know more than other people, know more truths than other people. But if you're going to search, shall we say, have people investigate some new area of physics, you're surely going to find it quite easy to separate out the experts from the non-experts in investigating. You can't say they're not experts because they don't know the answer. If you're going to decide who we're going to have look into this, you know who the
okay, but if we accept that they don't know the answer yet, then that's a
don't know the answer.
we wouldn't expect those experts to make claims about the truth of something when we know that they don't know yet.
No.
So it's a different type of use of experts, I would say.
Exactly.
Yeah, Luigi.
I have a question again about this your claim. Genuine disagreements among experts is very rare. Now, it seems to me that your view is really, you reach this conclusion just by definition, in the sense that we have a real expert if, only if there is a well-established knowledge about that domain. In this case, of course, it's extremely true. So, you offer 3 case studies, but I was unable to find in your talk a general argument about this claim. What's your general argument to say that can be a genuine disagreement among experts? It's not
maybe
sufficient just to give some example that can be questionable.
Maybe this is just deliberately kind of overstated to be provocative, and that I think that a lot of cases of so-called expert disagreement are not cases of genuine expert disagreement, because in fact the experts, when we talk about scientists, they generally they agree about the scientific bits, but very often they disagree about how it applies to life, or they disagree about what effect it might have on something in the future. And I would argue that when it comes to the future, there are no experts. So I don't have a definition of expert that I want to defend. I'm just suggesting that, probably I overstated this. Maybe that there are fields where experts disagree more often, but I think that a lot of so-called expert disagreement is not really expert disagreement. It's 2 experts disagreeing, but not necessarily disagreeing on something which they are both entitled to make claims about the truth of.
I know there are other questions, but I think it's time to go for coffee. But we can come back to these very core issues tomorrow, because the post-quantum races are central to the whole research project we are running today. Charlotte will lead you to the coffee place. It's that building there, but if you can follow Charlotte, and we'll try to be back on time for the next session at 11:30. It remains for me to thank Marty for a very good talk.
Thank you.